So now we look at example 2. Find dy dx for ln sine y squared minus x over y is equals to exponent power of 3y by using implicit differentiation. So again, for this, first I differentiate ln, second I will differentiate sine, third I will differentiate y squared. So when we come to the second part of this expression, you can see that this is x over y. So from here, we will apply quotient rule. So where the denominator is x, our u is x, v is y. So here is our u, this is our v. We will use quotient rule. Next, the final part of this expression, first we will differentiate exponent. Second, don't forget to differentiate 3y. So now I start to differentiate. So for the first part, first I differentiate ln, I should get 1 over sine y squared. So we have to rewrite the second and third part. Second, we will differentiate sine. So I should get cos, let's say put a bracket, y squared. This is the second part. Finally, third, I differentiate y squared. So I should get 2y. Don't forget the dy dx. Minus, so since this is a fraction or a rational function, when you want to differentiate rational function, we have to use quotient rule. So the formula here is v u prime minus u v prime over v squared is equals to, first we differentiate exponent, so I should have exponent, then rewrite the 3y. Next, differentiate 3y, I should have 3 dy dx. So now I try to solve the quotient rule. So in our quotient rule, u is equals to x, the denominator is u, v is equals to y. So u prime is equals to 1, v prime, suppose when I differentiate y, I should get 1. Because I differentiate y, I have to multiply by dy dx. So it's 1 dy dx, or I can write as dy dx. Because 1 times dy dx is dy dx. So now, here I try to solve cos y squared over sine y squared times, so here, so here is sine, so here is y squared, so here is y squared. So if I try to rearrange this one, this is 2y cos y squared. So 2y cos y squared over sine y squared, don't forget the dy dx, minus, now I try to substitute into the quotient rule. So v is y, u prime is 1, minus u is x, v prime is dy dx, over v squared. So our v is y, so here is y squared, is equals to 3 exponent 3y dy dx. So next, so cos y squared, so this is y squared, sorry, so just so here is y squared. So cos y squared over sine y squared. So this part, cos y squared over sine y squared. So if you still remember in our pre-calculus, so cos over y and cos over sine is cotangent. Cotangent y squared dy dx minus, so now from here I separate into two parts, y over y squared. So be careful with the negative. Let's say I change to red color. Negative is positive. So here will become x over y squared, x over y squared, dy dx is equals to 3 exponent 3y dy dx. So since I need the dy dx, so I will put the dy dx together. So here I can try to simplify. So next, 2y cotangent y squared dy dx. Y over y squared is 1 over y plus x over y squared dy dx is equals to 3 exponent 3y dy dx. Since I need the dy dx, so I will put the dy dx together. Means that I will move this one to the left hand side, 1 over y to the right hand side. So next step, 2y cotangent y squared dy dx plus x over y squared dy dx minus 3 exponent 3y dy dx will be equals to positive 1 over y. So from negative, when I move to right hand side, positive 1 over y. Same go to this one. From positive 3 exponent 3y dy dx, when I move to left hand side, here will become negative. Finally, here we have the dy dx. We can factorize the dy dx. So dy dx in a bracket. From here, I should have 2y cotangent y squared plus x over y squared minus 3 exponent 3y is equals to 1 over y. So finally, I divide this bracket to the right hand side. So I should have dy dx is equals to 1 over y divided by the whole bracket here, which is 2y cotangent y squared plus x over y squared minus 3 exponent 3y. So you can just left your answer in this form. So this is our dy dx by using implicit differentiation. The only key point here is when we differentiate y, you have to multiply by dy dx. Same go to here. When I differentiate y squared, I should get 2y dy dx.